Morning everybody. Today we're going to do some more work with trigonometry. We're going to finish off exercise 6c, which we started yesterday. Yesterday we were manipulating expressions and identities, try and make one thing look like something else. Today we're going to see that in action again, but at the same time we're going to try and solve an equation. So we're going to use those skills from yesterday to solve some trig equations. Solving trig equations, we did this last week, and you guys did this when you did your year 1 book, so this is the solving aspect, isn't a new skill, and you'll recognise that in a minute. However, the skill of doing what we did yesterday at the same time of trig equations is something new for us. So we're going to do that today. Monday we'll be looking at trig identities, which is quite tough, but also quite fun. And on Tuesday we'll be looking at inverse trig functions. We'll probably look at doing the test on Wednesday or Thursday next week. Okay, so here's just a quick video today, really, because we've got all the skills together. We've got all the skills, we just haven't stuck them together. So this question here says solve cosec squared theta equals 3 plus cot theta. So if we want to solve a trig equation, it would be best for us to try and write it in terms of sine theta equals something, or cos theta, or tan theta. And that's because we really know those graphs very well. You could do it in terms of sec, cosec, or cot. However, I'd recommend that you always try and get it into sine, cos, or tan theta, because you know those graphs so well. So looking at this question here, it's not immediately obvious what to do. And I just actually paused the video and just had a quick think about this. This is actually particularly not obvious today because we need some trig identities, which we won't do till Monday. So actually I'm going to just change this example. Apologies for that. We'll use this example on Monday. So instead of using that example, let's use this instead. It should make the point that I want to make. So sec squared theta equals 3 plus sec theta. Okay, so if we want to solve this, like I said, it would be good to get it in terms of either sine or cos or tan. In this case, we've got secs. Because these are secs, that means that they're 1 over coses. So it'd be good if we can get this in terms of cos somehow. One of the easiest ways for them to try and confuse you in some ways with doing trig equations is to try and force to get a quadratic in there. You can see here this is a sec squared, sec to the power of 1, and a sec to the power of 0 from this bit. So this is a quadratic equation which just needs rearranging. So we can get sec squared theta, and I need an extra thing in there. I need that line time to make this work. Sorry about that. Minus 2 sec theta. Take away 3 equals 0. Just stick a 2 in there because otherwise this isn't going to work very nicely. So from this original question of solving this in that range, I can rearrange this into a quadratic, and that will give me sec theta if I factorise this. Sec theta. I need to get a minus 3, and 3 is prime, so it's either plus 1 minus 3 or the other way around. In this case, because this is a minus 2, this has to be a minus 3 equals 0. So that implies that sec theta is equal to minus 1, or sec theta is equal to 3. So given that we have that, that means that 1 over cos theta equals negative 1, or 1 over cos theta equals 3. And so cos theta is just equal to minus 1 altogether. If I times this up here by cos theta and then rearrange this, I'll get this. Or if I times by cos theta and divide by 3, I get cos theta equals a third. So given that I've got these two bits here. What I need to do next is draw myself a diagram, so a graph of cos theta. So that's down to minus 180, that's 180 there. So if it's minus 1, then I've got two answers. I've got, if you stick cos theta equals minus 1 into your calculator, that will give you theta equals 180. And from the graph you also get minus 180. And then for cos theta equals a third, you can see that you're going to get two values here, roughly. To get the first value, bang it in your calculator. And you should get, I think it was 70 point something. Let me check. 70.5, and because that's here and and the symmetrical nature of this graph, we'll also have minus 70.5 degrees. So the solutions to this are these. I could go a bit further either way, but it says at the top here that it's between minus 180 and 180. I could have made this question harder by sticking 2 thetas in here, or maybe 5 thetas, or some multiple of thetas, and then you'd have had to at this line here said, okay, well let 5 theta equal x, or whatever it happens to be. But you guys have done that many times before. The main thing I wanted to show you was the fact that you could see a quadratic, or the fact that if you've got this an equation with sets in, or a mixture of them, all you need to do is try and manipulate them down into one thing only, so you can do these lines here. Okay, what I'd like you guys to do is just 2 questions today, with many parts, I'm sorry. So exercise 6c, can you have a go at question 6 and question 7? And if you get those done and you are particularly in the mood for it, then have a go at question 8 also. Okay, thanks very much. I've got an email about one of the questions from yesterday. I'll do that next and get that posted online. If anybody has any other questions from today's or yesterday's work, then please let me know. Thanks very much. Bye-bye.